Now we're getting serious. Let's do part A. Part A is parenthesis, base A raised to the 4/3 times base B raised to the negative 1/2, close parenthesis, times parenthesis, A to the negative 2 times B to the 5/2. Well, we don't need those parentheses because everything is being multiplied. So this is equal to base A to the 4/3 times A to the negative 2 times B to the negative 1/2 times B to the 5/2. Okay, now what I'm going to do is I'm going to consider the A's, since they're both have the same base. They both have the same base. I move things around. You see, I put the A's next to the A's, the B's next to the B's. So I can use a rule of exponents that says when you're multiplying the same base, you can write a single version of the base raised to the first exponent plus the second exponent. So it's 4/3 exponent plus a negative 2 times a single B raised to the first exponent, negative 1/2, plus the second exponent, 5/2. Okay, so we're going to simplify A. It's raised to the 4/3 plus, I need a common denominator, so I'll write 2 as 6/3, times B raised to the, well, let's see. Well, the good news is that the B was already with a common denominator, the negative 1/2 plus the 5/2 gives me a total of positive 4/2. Continuing my simplification, I have base A is, let's see, raised to the 4/3 minus 6/3 means it's base A raised to the negative 2/3 times B raised to the, let's see, 4 over 2 was 2. And finally, because we want an a positive exponent, we're going to flip the A to the negative 2/3 upside down and multiply it against the B squared. Top times top over bottom times bottom. It'll give us B to the second over A to the positive 2/3. Part B is parenthesis 64m to the 1/2 n over m to the negative 2 times n to the 4/3, all raised to the 1/2 power on the outside. Now, there are several ways you could do this. I am going to concentrate on the interior of the parenthesis and bring the 1/2 power along for every step. Don't lose that exponent. And after I've simplified sufficiently on the inside, I'll apply the 1/2 power. So the first thing I'm going to do is separate the inside. Put the number part times the m's together times the n's together. And then close the parenthesis and bring the 1/2 power along. Now I'm going to apply rules of exponent. That's 64 inside the parenthesis times m raised to the top exponent minus the bottom exponent times n raised to the top exponent minus the bottom exponent, all of it raised to the 1/2 power. Okay, so let's go ahead and do the addition, or subtraction, I should say, of the exponents. We need to get common denominators for our exponents because they're fractions. So this is equal to 64 times m to the 1/2, double negative makes plus the 4/2 times n to the 3 over 3 minus the 4/3, all raised to the 1/2. So now I have common denominators. I can do the addition and subtraction in the exponents. That gives me 64 times m raised to the 5 over 2 times n raised to the negative 1 over 3, all to the 1/2. Now I'm going to apply the 1/2 power to each of the factors that are multiplying inside the parenthesis. We're allowed to distribute the exponent, the 1/2, against all the factors, but if they were being added, they're not factors. Remember, you can't distribute the exponent across addition, only across multiplication. So that's the first factor, 64 raised to the 1/2, times the second factor, m to the 5/2 parenthesis raised to the 1/2, times the last factor, n to the negative 1/3 raised to the 1/2. So I distributed 1/2 power across multiplication. For the 64 raised to the 1/2, I'm going to write that as the nth root, in other words, the second root, the square root of 64. Times, for the next term, factor, I'm going to take m and raise it to the product of 5/2 times the 1/2, 5/2 times 1/2, and then multiply that by n raised to the negative 1/3 times the 1/2, because the rules of exponents say when you raise a power to a power, you multiply the exponents together. Okay, the square root of 64 is 8 times m to the 5/4, that's the product, 5/2 times 1/2. times n to the negative 1 over 6. That's the product of negative 1/3 and 1/2. So I get 8 times m to the 5/4 times 1 over n to the positive 1/6. Multiply it all together, and my final answer is 8m to the 5/4 over n to the 1/6. And I know I'm simplified because I have no negative exponents and I have the least quantity of bases possible. When we started, we had lots of m's and n's floating around. Now we just have a single m and a single n, and all the exponents are non-negative.